Okay, let's start with the number. 3.1%. If you heard something had a 3.1% chance of happening, would you, worry much?
Probably not, right? For most things, it sounds pretty small. A blip.
Yeah, just a statistic.
But-
But for a very specific group, these planetary defenders, 3.1% was actually, well, terrifying, unprecedented.
Exactly. We're talking about asteroid 2024 YR4, estimated somewhere between, let's say, 130 and 300 feet long. Pretty chunky.
Big enough to matter,
Oh,
definitely.
yeah. And on February 18th, not too long ago, astronomers basically confirmed it had this 3.1% chance of hitting Earth in 2032.
And just to be clear, that 3.1%, that sounds low, but in asteroid terms.
It was huge. It was actually the highest chance an asteroid that that size had ever posed, ever.
Wow. Okay. And it wasn't like it was heading for the middle of the Pacific, was it?
No, far from it. The potential impact zones included really densely populated cities. Think Mumbai, Lagos, Bogota. Yeah. The worst case scenario wasn't just, damage. The description used was outright total ruin.
Total ruin. Okay.
Yeah.
That's serious. So what happens then? What's the immediate global reaction to that kind of news? Must have been frantic.
It was intense, absolutely. But interestingly, despite how serious it was, the scientists and engineers involved also found it. Well, the quote was a little bit exciting.
Exciting. How so? Like in a terrifying way.
Sort of. It became this sudden real-world test of everything they'd been preparing for, all the planetary defense plans. High-level talks kicked off immediately about, how to deflect it.
Deflection. Like what were they actually considering?
Everything was on the table.
Yeah.
Ramming it with a spacecraft like the DART mission or even nuclear weapons.
Nuclear weapons
Wow.
in space. Has that ever even been considered seriously before?
It's been theorized, but yeah, launching a nuke into deep space to hit an asteroid, that's uncharted territory. But the stakes were that high.
Okay, so this is the setup. A tiny blip becomes this potential catastrophe, triggering a global race against time. So today, in this deep dive, we're going to get into that inside story. How over just 2 really intense months, this whole global network, astronomers, engineers, observatories, found this thing, tracked it, mapped its path, planned for the worst, and then, well, ultimately ruled it out.
Yeah, the timeline was incredibly tight. The pressure was immense. Olivier Hainaut, an astronomer involved, he put it perfectly. It was not an exercise. This was the real thing. We really had to get it right.
So you're going to hear how they tracked that rising danger, that 3.1%, and how kind of against the odds it felt like they figured out Earth was safe.
It all kicked off back on December 27th, 2024, at the ATLAS telescopic network. That's in Hawaii.
ATLAS, that stands for Asteroid Terrestrial Impact Last Alert System, right?
That's the one. Funded by NASA, rose robotically, just constantly scanning the sky. Larry Deneau, one of the principal investigators there, he was the first to spot the detections. Just, a tiny white pixel on a black background.
And these ETLA systems, they're really crucial, aren't they? Kind of the front line.
Absolutely. Kelly Fast over at NASA, she's the acting planetary defense officer. She calls him exactly that. The first line of planetary defense.
So ATLAS spots it, then what?
They send the observation straight to the Minor Planet Center, which catalogs these things, and boom, a new discovery, 2024 YR4. Funny thing is, they later found it in images from December 25th.
Christmas Day.
Yeah, it actually made its closest approach to Earth that Christmas Day. Sneaky?
So, okay, it's spotted. How do they go from tiny white pixel to, potential threat? How's that trajectory and risk calculated so fast?
Right, that's where Davide Farnocchia comes in. He's at NASA's Center for Near-Earth Object Studies, CNEOs, out in California.
CNEOs. Got it.
And this guy, he tracks like 1.4 million objects.
Yeah.
Apparently very calm about it. His job is plotting potential paths, checking for overlaps with Earth's orbit. He uses this automated system called Sentry.
Sentry, he helped code that, right?
Yep. It's like this digital brain constantly crunching numbers, refining orbits using gravity, the pull of planets, moons, everything. And back in late December, even with just a little bit of data, Sentry and a similar European system called Aegis, they both concluded, non-negligible chance 2024 YR4 hits Earth in 2032.
Non-negligible. Okay. But you mentioned the size estimate was really wide at first, like 65 to 500 feet. That's a huge difference. Why so hard to pin down?
That's a really key problem. I mean, think about it. A small, really reflective rock can look exactly the same as a much bigger, darker one through a lot of telescopes.
Right. Brightness isn't size.
Exactly. And the difference matters hugely. A 65-footer might break windows, cause a big sonic boom. A 500-footer, that could vaporize a city center.
Okay, yeah, big difference.
So to get a better size estimate, you need the big guns. That's where the European Southern Observatory's very large telescope, the VLT, came in, down in Chile.
The VLT, one of the
Yeah.
best, right?
Oh, yeah. Mid-January, they pointed it at YR4, and that helped narrow it down. Still a range, but better. At least 130 feet long, maybe up to 300 feet.
Okay, so definitely big enough to wipe out a city. Still very much a threat.
Absolutely. Annihilation potential was still there.
So by the end of January, the risk is clear, the size is narrowed down, sort of. What happens then at the official global level?
Well, Marco Finucci, he's a dynamicist at Europe's NECC, that's their Near-Earth Object Coordination Center. He pointed out that YR4 had a greater than 1% chance of impact on December 22nd, 2032.
1%. That doesn't happen often.
Very rarely for something this size. He even admitted it was exciting to see, sci-fi movie stuff becoming real.
Ah, okay.
So as those odds started creeping up, the International Asteroid Warning Network, IAWN, it's a UN-backed group, they issued a public alert, sent it out to governments worldwide.
Ah, so that's when it hits the news.
That's when everyone really started paying attention, yeah. Media, public, and astronomers like Larry Deneau at ATLAs, they started getting urgent emails from NASA saying, basically, all hands on deck. Any telescope that could track this thing needed to.
But there was a huge problem brewing, wasn't there? It had already passed Earth on Christmas Day.
Exactly. It's heading away from us, back out into space,
Yeah.
and getting fainter fast.
So a race against the clock to keep observing it before it disappeared?
Absolutely frantic.
Yeah.
If they lost it, the impact odds would just hang there, uncomfortably high, maybe until 2028, just 4 years before potential impact. Finucci at NEOCC said, in that situation, we would have been in trouble. Big trouble. The hunt was seriously on.
Wow, I can feel the tension just thinking about it. Were those deflection talks getting more serious then? Like the just-in-case planning?
Oh, yeah. Early February, things escalated. The UN-supported group, SMPAG Space Mission Planning Advisory Group, they met in Vienna. High-level talks specifically about how to deflect or maybe even obliterate YR4 just in case.
We're talking nukes and ramming.
Yep. Ramming, nukes. But the problem is, there's no single perfect solution, right? Asteroids can be weird. Sometimes they're not solid rocks. They're more like gravel piles flying together. Hit it wrong.
And you turn one big problem into lots of smaller problems.
Exactly. One cannonball becomes a face full of shotgun pellets. Not ideal.
And they only had 8 years to figure this out and potentially build and launch something. That's tight.
Incredibly tight. Hainaut mentioned the unprecedented tempo of their discussions. This was definitely not a drill.
Okay, so things are tense, but more observations were coming in, right? Did that help?
Sort of.
Yeah.
But not in the way you'd hope initially. The new data helped rule out some possible orbits, yeah. But Earth stubbornly remained a potential target. And worse, the odds actually started bubbling up, as Deneau put it.
Bubbling up, not down.
Nope, up. By February 6th, they hit 2.3%. That's a 1 in 43 chance.
1 in 43. How does that compare historically?
Only one other asteroid of similar size, Apophis back in 2004, had briefly posed a higher risk, 2.7%. So, yeah, they were getting to record territory, really uncharted waters.
Okay, so ground telescopes are struggling as it gets fainter. The odds are climbing. What other cards did they have to play? Any, ace in the hole?
Thankfully, yes. There was a potential space-based wild card, the James Webb Space Telescope, JWST.
JWST. For asteroids, I thought it looked at distant galaxies.
Mostly, yeah. But it turns out it's graded infrared. Ground telescopes struggle with infrared because our atmosphere messes with it. But JWST, sitting 1 million miles out, no atmosphere problem.
So it could see the asteroid's heat.
Exactly. It can track the thermal glow long after ground telescopes lose the visible light. And what's really interesting is planetary defenders had only recently figured out JWST could even do this effectively.
Wow, talk about timely.
Right, so a proposal went in super fast, got accepted February 5th. The hope was, even if the odds stayed high, maybe JWST could nail down the size better. Hopefully find it was on the smaller, less city vaporizing end of that 130 to 300 foot range.
But JWST couldn't look right away, could it? There was a delay.
Yeah, scheduling. It couldn't observe until early March. So while they waited for JWST, the ground-based folks were still pushing like mad.
Who else got involved?
On February 7th, Gemini South Telescope in Chile joined the effort. The odds dipped slightly to 2.2%. Still high. Then there was the Magdalena Ridge Observatory MRO in New Mexico.
MRO.
Yeah, run by Eileen Ryan and her husband. Kind of a mom-and-pop organization, as they put it, but with this incredibly agile telescope originally built to track missiles. Super fast.
Impressive, but even they hit a wall, right? Something unavoidable.
Yep. Mid-February, the ultimate enemy for ground-based optical astronomy, the full moon.
Ah, the moon. Too bright.
Totally. Just washes everything out. Blighted the telescopes for about a week. To know is pretty blunt. We abhor the moon. So everyone just had to wait, knowing the clock was ticking, and if they didn't get more data soon after the moon waned, those odds would stay worryingly high.
Okay, so the moon finally fades, February 18th. The big telescopes fire back up. What happened?
New observations started trickling in. Sentry and Aegis, those automated systems, crunched the new numbers. And the news was not good.
Worse.
Worse. The odds of an Earth impact jumped to 3.1%.
There it is, the big one.
That was it. That officially made 2024 YR4 the most dangerous asteroid in terms of impact probability for its size ever discovered.
Headlines must have gone crazy.
Oh, yeah. Worldwide. People were starting to wonder, is this another thing we have to worry about? Apocalypse fatigue is real.
Yeah. But the asteroid hunters, they kept cool.
They did. They remained pretty steadfast. They have faith in the process. They knew, theoretically, more observations should eventually make the odds drop to zero.
Yeah.
It's just how orbital mechanics works when you refine the data.
But they still explored other options, like redirecting a spacecraft.
They did. They looked into maybe nudging NASA's Lucy spacecraft, which was out there, to get a closer look. But YR4 was just too fast, too far away. It really felt like JWST was the last best hope.
But then something happened before JWST could even look.
Yeah, just one day later, February 19th. The VLT, MRO, others, they managed to catch it again. Barely, but they did. That new data went straight into the prediction systems, and suddenly the odds dropped, halved, actually, down to 1.5%.
Okay, progress. Finally heading in the right direction.
Right, and then the very next day, February 20th, Tsuyoshi Terry, he's an astronomer at Japan's Subaru telescope, also in Hawaii. Huge telescope. He finally nailed it. Got really good data.
And that was the key.
That seemed to be the tipping point. He added his observations to the mix, fed it into the system, and all of a sudden, poof, the asteroid basically lost its threat status. The odds plummeted.
To what?
Just 0.3%.
Yeah. Wow. From 3.1 to 0.3 in like 2 days.
Yeah.
So I'm picturing, mission control, people curing, popping champagne, high fives.
Hope. Not even close. It was remarkably low-key. Remember, these astronomers are scattered all over the planet, different time zones.
Right. No central control room.
Exactly. So instead of cheers, it was more like a flurry of modestly worded emails congratulating each other. The digital equivalent of a quiet nod or a handshake.
Seriously, that's it.
Pretty much.
Yeah.
Terai, the Subaru guy, he just said, "It was a relief. I was very pleased that our data contributed to put an end to the risk of 2024 YR4.
It's kind of funny, isn't it? This huge global effort, staring down potential doom, and the moment it resolves is just quiet satisfaction and polite emails.
Almost anticlimactic, but profoundly important, obviously.
Profoundly satisfying for them, I bet. Just quietly doing the job.
So what happened after that 0.3%? Did it go to zero quickly?
Yeah, pretty fast. Just a few days later, February 24th, with even more observations pouring in, IAWN, the warning network, officially issued the all clear. All clear. So the odds went down.
Way down. By then, the chance of it hitting Earth was 0.0004%. That was 1 in 25,000. Basically negligible.
Yeah.
And today, with all the data, the odds of 2024 YR4 hitting Earth in 2032 are precisely zero. Gone.
Zero. Wow, what a turnaround.
Larry Deneau, the ATLS guy, he even joked he was kind of fun while it lasted.
It's kind of fun. Easy for him to say, maybe.
But Kelly Fast at NASA, she really summed it up perfectly. In my mind, the observers and orbit teams were the stars of this story. Just an incredible display of skill, coordination globally.
Absolutely, going from 3.1% to zero like that. So looking back now beyond just the relief, what are the big takeaways? What did we learn from this whole YR4 episode that actually makes us safer next time? This battle-tested experience, as you called it.
That's really the crucial outcome, isn't it? Beyond just dodging this one bullet, it really hammered home how vital that seamless real-time data sharing is. Across countries, across observatories, more eyes on the sky equals more safety. Simple as that.
Right, the coordination was key.
Totally. And it also showed the need for agility. Like being able to pivot and use an instrument like JWST for asteroid tracking. Something it wasn't really designed for, or at least wasn't thought of for that initially. That adaptability is huge.
And the automated systems, Sentry and Aegis.
Absolutely critical.
Yeah.
Especially in those early days with limited data. Having those systems constantly running, providing those first crucial, even if uncertain, warnings, that's indispensable. These aren't just theoretical improvements. They're concrete things learned under pressure that directly strengthen our planetary defense. We're genuinely better prepared now for when the really big one shows up.
It's amazing how that meticulous, sometimes quiet work, sending emails instead of cheering, is literally what keeps us safe.
It really is.
Okay, so Earth is safe, 0% chance, but you mentioned there's a twist, a postscript to this story.
Yeah, this is where it gets really fascinating. So remember, JWST was scheduled to observe YR4 in March.
Yeah, even though the threat to Earth was gone by then.
Exactly. They looked anyway. JWST observed it in March and then again later in May. And those super precise observations allowed astronomers to calculate something. Pretty wild.
Don't tell me it's looping back.
No, not hitting Earth.
Yeah.
But there's now a calculated 4.3% chance that 2024 YR4 will hit the moon in 2032.
Hit the moon. Seriously, 4.3%. That's higher than the Earth risk ever got.
It is a significant chance this 200-foot rock slams into the moon.
What would that even look like?
Think about it. An explosion equivalent to hundreds of nuclear bombs going off,
Right.
probably on the side of the moon facing us.
Facing Earth, so we'd see it.
Oh, yeah. Larry Deneau say, it may hit the moon. Everybody's still very excited about that. You'll likely be able to see the bright flash of impact from Earth with your naked eye.
Wow. Just wow.
Deneau also said, if that does happen, it'll be amazing. And from a scientific perspective, it really would be.
How so?
It's this incredible, unique opportunity to study a significant asteroid impact up close, relatively speaking. Test their prediction models, see the crater form, analyze the ejecta plume, all without any danger to us here on Earth.
So it's like a natural experiment playing out right next door.
Exactly. A spectacular finale for 2024 YR4, this object that went from a tiny pixel to a global concern. It's, as Deneau put it, a thing we can plan for without having to defend the Earth, a scientific spectacle instead of a planetary defense emergency.
What a story. From potential doom to a potential lunar fireworks show.